July 25, 2000. Charles de Gaulle Airport, Paris. Air France Flight 4590. The Concorde is lining up on runway 26, right?
This isn't a standard commuter flight. It's a luxury charter. 100 passengers, mostly German tourists, heading to New York to board a cruise ship. The ticket price? Astronomical.
The aircraft is FBTSC, a technological marvel. 4 Rolls-Royce Olympus turbojets with afterburners. It's designed to cruise at twice the speed of sound.
But the profit margins are thin. Concorde burns fuel like a rocket. Every minute of delay costs thousands. The captain, Christian Marty, is under pressure to keep the schedule.
16:42 p.m., the tower clears them for takeoff. The throttles go forward. The reheat kicks in. 4 engines dumping raw fuel into the exhaust for maximum thrust.
They are heavy, overweight, actually carrying a full load of fuel plus luggage. They need every inch of that runway.
The speed builds. 100 knots. 150 knots. They are approaching V1, the point of no return. You cannot stop the plane after this speed.
And that's when the timeline splits. 5 minutes earlier, a Continental Airlines DC-10 took off from the same runway. It left something behind.
A wear strip, a piece of metal meant to protect the engine cowl. It's 43 centimeters long, made of titanium alloy.
It shouldn't have been titanium. The manual specified stainless steel. Titanium is harder. It doesn't yield. A mechanic at Houston improvised the repair weeks ago.
The Concorde's front wheel runs over it. Nothing happens. But then the main landing gear hits. Tire number 2.
The tire is spinning at over 200 miles per hour. It's under immense pressure. When it hits the titanium strip, it doesn't just puncture, it explodes.
A 10-pound chunk of rubber detaches. The centrifugal force turns it into a ballistic projectile. It fires upward and backward.
It misses the engine intake. That would have been bad, but survivable. Instead, it strikes the underside of the left wing.
Impact physics are strange here. The rubber doesn't penetrate the wing skin. It hits with such force that it creates a shock wave.
A ripple effect. It travels through the metal and into fuel tank number 5. The tank is full. Liquids don't compress.
Hydrodynamic ram effect. The shock wave moves through the kerosene and blows the tank open from the inside out. A massive rupture.
Fuel pours out at 100 liters per second, a literal waterfall of kerosene. It creates a mist right in front of the engine intake.
The engines are on afterburner. A 10-foot flame is shooting out the back. The fuel mist ignites instantly.
The tower controller screams, "Concorde 4590, you have flames behind you." But it's too late. They are past V1.
Pilot Marty has no choice. He has to fly. He pulls back on the stick. The burning plane lifts off the ground.
But Engine 2 is dying. It's ingesting its own fire. It surges and loses power. Engine 1 starts to choke on the debris.
You are low. You are heavy. You have lost 50% of your thrust on the left side. The aircraft starts to yaw violently. It wants to flip over.
The fire is melting the wing structure. The hydraulic lines are vaporizing. The landing gear won't retract because the doors are destroyed.
Drag is increasing. Speed is decreasing. They are a flying brick on fire. They can't climb. They can't accelerate.
They are heading straight for the town of Gonesse, a hotel, the Hotelissimo, filled with staff and guests.
The physics of flight abandon them. The left wing stalls. The nose drops. The aircraft rolls inverted.
Crash time, 16:44 p.m., less than 2 minutes after takeoff. The impact is catastrophic.
The fireball consumes the hotel. All 109 on the plane die instantly. 4 people on the ground are killed.
The financial shockwave hits London and Paris immediately. Air France stocks plummet. The entire Concorde fleet is grounded within hours.
It wasn't a bird strike. It wasn't a bomb. It wasn't pilot error.
It was a sloppy repair job on a different plane, from a different airline. Negligence.
One strip of metal V's a supersonic jet. The metal one. Let's dissect the physics of the impact. Because tire hitting wing sounds too simple for a catastrophe of this magnitude. When that tire exploded, A large chunk of rubber weighing roughly 4.5 kilograms slammed into the underside of the left wing. At over 300 kilometers per hour, it struck directly beneath fuel tank number 5. The critical detail here is that the rubber did not penetrate the wing's skin. Instead, the violent impact caused the wing to flex inwards, creating a massive pressure wave inside the fuel tank, known as a hydrodynamic ram effect.
While Mark focuses on the physics, we have to look at the chain of negligence that placed that debris on the runway in the first place. The metal strip didn't just fall from the sky. It fell from a Continental Airlines DC-10 that had taken off. Only 5 minutes prior, the investigation revealed that a mechanic named John Taylor had installed a wear strip on the engine cowl door support, but he didn't use the authorized stainless steel part required by the manufacturer's manual. He fabricated a replacement out of titanium, a much harder, unforgiving metal, and secured it with rivets that were too short for the job, effectively creating a ticking time bomb.
Because that strip was titanium, it didn't flatten or bend when the Concorde's tire rolled over it. Instead, it acted like a scalpel, slicing deep into the tire's structure and initiating the disintegration. Once the fuel tank ruptured from the shockwave, kerosene began gushing out at an uncontrollable rate of nearly 100 liters per second. This massive fuel leak immediately ignited, likely due to a spark from the damaged landing gear wiring. Contact with the hot engine parts, creating a blowtorch effect that trailed behind the aircraft as it desperately tried to gain altitude.
The logistical failure here is staggering because it highlights a complete breakdown in maintenance protocol at Continental Airlines. The mechanic not only used the wrong material, but he also didn't follow the specific drilling template for the rivets, leaving the strip insecure and prone to fatigue. This wasn't a complex engineering failure of the Concorde itself. It was a result of cutting corners in a workshop thousands of miles away. That singular decision to save time and use scrap metal instead of ordering the correct part bypassed all safety redundancies and doomed 113 people.
The situation in the cockpit became impossible almost instantly because the fire wasn't just burning the outside of the plane, it was choking the engines. As the fire raged, engines 1 and 2 began ingesting hot gases and unburned fuel, causing them to surge and lose thrust violently just as the plane needed maximum power to climb. The pilot, Christian Marty, was fighting a losing battle against aerodynamics because the fire was also melting the aluminum wing structure, destroying the elevons required to steer, and keeping the landing gears stuck in the down position, which added massive drag.
Financially and reputationally, this exposed a vulnerability that the aviation industry had ignored for decades. The danger of foreign object debris, or FOD. Before this crash, a tire blowout was considered a minor hazard, something that might damage a flap or a hydraulic line, but never a catastrophic threat to the fuel tanks. The inquiry revealed that Concorde's design, dating back to the 1960s, lacked the armor or liners in the fuel tanks that could have prevented the rupture, a safety upgrade that would have cost millions but was deemed unnecessary until the disaster made it mandatory.
By the time the aircraft reached V1 speed, the physics of flight had already abandoned them. The plane was heavy, dragging its landing gear, losing thrust on the left side, and essentially dissolving in midair. The asymmetry of lift caused the plane to bank sharply to the left, exceeding an angle of 100 degrees, at which point the wings lost all ability to generate lift and the aircraft stalled, dropping out of the sky like a stone. It wasn't a crash in the traditional sense of a pilot losing control. It was a mechanical execution, where the machine simply ceased to be airworthy.
The final verdict placed the blame squarely on the unauthorized maintenance of the DC-10, leading to criminal charges against Continental Airlines and the mechanic involved. It was a stark reminder that in aviation, economy-class maintenance on one plane can destroy a first-class supersonic jet on the same runway. The payout and legal battles lasted for over a decade, but the immediate result was the shattering of the Concorde's image of invincibility, proving that even the fastest machine on Earth could be brought down by a cheap, unauthorized strip of metal. The crash of Flight 4590 didn't just kill 113 people, it effectively killed the commercial supersonic transport industry overnight. Immediately following the disaster, Air France and British Airways grounded their entire Concorde fleets, and the investigation revealed that the passengers were mostly German tourists on a once-in-a-lifetime trip, a demographic detail that turned a technical failure into a heartbreaking human tragedy that dominated global headlines for months. The financial fallout was catastrophic, with Air France's stock taking a massive hit and the brand suffering irreparable damage, as the image of the burning jet became the defining symbol of the risks associated with high-speed travel.
Engineers spent the next year frantically trying to redesign the Concorde to prevent this specific failure mode from ever happening again, focusing on the vulnerability of the fuel tanks. They developed and installed Kevlar-lined fuel tanks, essentially bulletproofing the fuel cells against debris impact, and switched to Michelin NZG tires, near-zero growth tires, which were designed to be far more resistant to foreign object damage and less likely to explode into shrapnel. These modifications added significant weight to an aircraft that was already pushing the limits of physics, reducing its payload capacity and making it even harder to operate profitably.
Despite the millions spent on safety upgrades and a triumphant return to service in November 2001, the timing couldn't have been worse, because the relaunch happened right after the September 11th attacks, which had already decimated the global aviation market. With air travel demand at an all-time low and fuel prices rising, the Concorde became a financial black hole for both airlines. The elite business travelers who were the bread and butter of the service simply weren't flying anymore. In 2003, less than 3 years after the crash, both operators announced the permanent retirement of the aircraft, marking the end of an era not because of safety, but because the economics were no longer sustainable.
The legacy of Flight 4590 isn't just in the history books. It changed how every major airport in the world operates on a daily basis regarding runway safety. Today, the concept of a FOD walk, foreign object debris walk, is a standard, critical procedure where ground crews physically inspect runways for even the smallest piece of trash, metal, or luggage hardware. We learned the hard way that a tiny strip of titanium, irrelevant to a massive DC-10, acts like a kinetic weapon against a high-performance machine like the Concorde, proving that in aviation, there is no such thing as a minor piece of debris.
Legally, the blame game dragged on for over a decade, with French courts initially finding Continental Airlines and the mechanic criminally responsible for involuntary manslaughter, a verdict that was later overturned on appeal. Though civil liability remained, it stands as a grim lesson in the butterfly effect of negligence. A single unauthorized repair done to save time and money on a completely different aircraft triggered a chain reaction that destroyed a billion-dollar program and cost over 100 lives. It proves that, in high-stakes industries, the cost of cutting corners is always paid in blood. Eventually,
The Concorde was a marvel of engineering that was defeated by a scrap of metal and simple physics, reminding us that speed is nothing without structural integrity. Inspect your gear, respect the tolerances, and never assume the runway is clear just because the tower says it is. Stay sharp,